Okay, let's go through this DC circuit question. So it's a bit hard. So in which circuit is the potential difference between P and Q greater than 0? Okay, so for this question, right, maybe I use your option C to illustrate idea. So for example, right, look at option C. Apparently these 10 and 10 ohms, they are connected in series to each other. And of course, this whole thing right here is 6 volts. Or likewise, for the second branch, right, this whole thing right here is also 6 volts. Okay, so let's see how do we actually distribute the 6 volts across the first and second branch. So for example, because looking at this, we know that this is 3 volt. This is also 3 volt. Why is these 3 and 3? Because, for example, I just draw a pure series circuit. So for example, it's like that, 10 ohm, 10 ohm. So this is 6 volts. So you can see that apparently, right, this is 10 and of course this is 10. So they are equal resistance, meaning you need to distribute equally. So for example, I got $6. You give this person $3, right? Then you give this person another $3. So that's why I get 3 here and 3 here. Okay, what about the second branch? Okay, second branch, likewise, right, 5 and 5, meaning that you will actually get 3 volt here and 3 volt. Okay, so now let's determine what happened if I actually connect not potential difference, but I connect a voltmeter across P and Q. Okay, so if I connect across P and Q, I will actually get a 0 volt reading. Why is that so? Because apparently, if you just imagine, okay, from here all the way to here, so before I go through the first 10 ohms resistor, right, all this part is actually your 6 volts. Then after that, I cross over to the this part, right? So the potential is actually 3 volt here. So this is the potential, not the potential difference. So 6 volts here is also known as potential. And then this is also potential. So next thing is, if I cross over the second 10 ohms, right? So at this point here is 0 volts. So of course, I go back home with 0 volts. So I go back home like that. So you can see 6 volts, then after that 3 volts, then 0 volts before I go back home. Okay, likewise, if I continue to the second branch here, so this part right here is also known to be 6 volts potential. So you must know the difference between potential and potential difference. Okay, then you cross over to the first 5 ohms resistor. So at this point is 3 volts, because you give away $3 already, right? So it's left with 3 volts. So at this point, right, the potential is 3 volts. Then after that, you continue to the second 5 ohms, right? You cross over. At this point, this part right here is 0 volts already. Then you go back home. So you can see all these are all the potential given. Okay, so if I connect a voltmeter across P and Q, right, apparently you can see that at point P is 3 volts. At point Q is also 3 volts. So you just use 3 minus 3, because voltmeter is measuring the potential difference. What is the meaning of potential difference? One number minus the other number. So 3 minus 3, you will get 0 volts. So that's why C cannot be the answer, because they want greater than 0. Okay, what about option D? Okay, option D, let's see why is this the correct answer. Okay, first, for example, first branch, second branch. Okay, first thing, I have a potential right here. So all this part, the potential is known to be 6 volts. Okay, then after that, I cross over to the first 5 ohms. Apparently, right, what is the potential right here? So before you can calculate potential, you must determine what is the potential difference first. So for example, potential difference here and here. So this is 5 ohms. Then after that, these are 10 ohms, right? So you obviously you can see that this is 4 volts. This is 2 volts. So the potential difference across 5 ohms is 2 volts. The potential difference across 10 ohms is 4 volts. Why is that so? Because you just think about it, right? For example, okay, I draw a pure series, 5 ohms here. Then after that, 10 ohms. So this is 6 volts, right? So you can see, this one is 5 ohms, right? This is 10 ohms. So definitely, I must give more potential difference to the 10 ohm, because remember, right, R is directly proportional to V. The greater the R, the greater the V. And how much greater? Twice greater. So for example, right, this will be 4 volts. This will be 2 volts. No, this twice, right? Okay, so now I already determine what is the potential difference already across the 5 ohms and 10 ohms, right? So you can see that I must give $2 to this person and I must give $4 to this person. Okay, at this point right here, I have $6, right? Okay, now I cross over at point P. I'll be left with $4, meaning 4 volts. In other words, 4 volts. Okay, then I cross over to the 10 ohms, right? So at this point right here, maybe I use this. Okay, at this point right here is 0 already because I must have 0 volts before I go back home. So at this point is 0 volts. Okay, so now I determine what is the potential at point P. Okay, what about the second one? Okay, second branch. So maybe I use this. Okay, so at this point they are all 6 volts. So this is 6 volts. So this is the potential. Okay, now you cross over to the first 10 ohms, right? So apparently we know the potential difference across here is 4 volts, and of course the potential difference across the 5 ohms is 2 volts. Okay, cross over to 10 ohms, right? You must give $4, meaning at this point, right, your potential at point Q will be 2 volts. Then after you cross over again, right, to the so-called 5 ohms, at this point you must have 0 volts, and then go back home. Okay, so based on point P and Q, right, apparently if you connect a voltmeter right here, so you connect a voltmeter, you will see that there's a reading registered in the voltmeter. So what is the reading? So the reading is 4 minus 2. So that's why the answer for this question, right, should be option D. So of course you can do likewise for option A and B. So for example, maybe I do option A and B in this video. So 6 volts. So same thing. This is 4 volts. So you must give this person 4 volts. You must give this person 2 volts. So of course this one is also 4 volts. This one is also 2 volts. Okay. So at this point, right? Okay. So all the way here is 6 volts potential. After that, you cross over to the 10 ohms. At point P, you must give $4 already, meaning you'll be left with $2 at point P. And then after that, again, right, you cross over to 5 ohms. Then at this particular point, you have 0 volts or $0 because you give $2 already. Right? Then you go back home. Okay, likewise for the second branch. So second branch is here. So okay, at this point the potential is 6 volts. Okay, then after you cross over the 10 ohms, so you must give $4, means you are left with $2. So this is your potential. So the 2 volts here that I write here and here, right, they are known as potential. Okay, then you cross over another 5 ohms, you'll be left with 0 volts. Okay, so with this, right, I connect a voltmeter across P and Q. So you'll see 2 minus 2, you'll get 0 volts. That's why A cannot be the answer. And likewise for B, right? Okay, so B at this point and this point. So what is the potential difference? The potential difference across this is 2 volts. This is 4 volts. This is the potential difference. This one likewise is 2 volts and this is 4 volts. Okay, so let's do the same idea again. So for example, right, 6 volts. Okay, so I go here, right? So at this point, the potential, for example, potential right here is 6 volts. Okay, then after I crossed over the 5 ohms, right, the first 5 ohms, I must give $2 already. So means 6 minus 2, 4 volts. So the potential at point P is 4 volts. Then I cross another one, 10 ohms, right? So this thing, I have 0 volts already. Then after I go back home. Okay, the next thing is right here. So for example, I am here. So at this point, the potential, same thing, is 6 volts. Okay, you cross over the first 5 ohm. At point Q, you give $2, right? $6, you give $2, left $4. So your potential at point Q is 4 volts. Then you cross another thing over. So at this point, you must have 0 volts. Yeah, then you use a voltmeter to connect. Then you realize that, you will get a 0 volts. Because 4 minus 4 is 0. So that is how we actually solve this question.